In this lesson, we're going to be talking about capturing packets. So capturing packets is a critical component to doing any sort of network troubleshooting or diagnosis. It's a really critical skill for any network engineer or, frankly, security engineer or pretty much anybody who does any sort of work on networks. As we go through these different lessons, we'll be doing a lot of packet captures, and not only packet captures, but just looking at different packet captures. So we're not only going to be capturing packets, we are going to be examining captures that have been done so we can dissect different protocols and take a look at how they work and the different requests that are going on. You can see here I've actually got a packet capture in process. I'm not actually storing this one. It's just all of the different requests that are going by. And it's really just a summary here. So you can see the different source and destination addresses and the protocols that are being used, as well as the different ports that are in use. And again, we're going to get into what all of those different words mean and how they work technically. And we're going to describe all of that in different lessons. Right now, I just want to talk quickly about just capturing packets and the importance of capturing packets and the different types of packets that you're going to run across. You can see here, I've got some IP packets. You can see some ARP packets. You can even see some IPv6 packets. If you're looking, you see IP6 in the second column as the things are scrolling by. Now, what I'm looking at here primarily is traffic that is destined specifically to my PC. So you can see, just scrolled off the screen, I'm actually going to cancel this request, and I'm going to scroll back up, and I'm going to look for these words that I really wanted to highlight here. So at the top of this terminal window, you'll see unicast. So anything that is directed specifically to me is a unicast packet. The reason it's called unicast is uni is a prefix meaning one. So we are sending a packet to one machine. Therefore, we are doing a unicast. So you can see a unicast packet there. Now, if I scroll down a little bit, there were some other packets. There we go. At the top of the screen again, you'll see broadcast. Now, a broadcast packet is actually a packet that is destined for multiple systems, or frankly, every system. Any device on the network would get a broadcast packet because I am sending it across a broad spectrum of hosts. So a broadcast would be sent to every device on a particular network. So that's a broadcast. There are protocols that use primarily unicast packets, and there are protocols that use primarily broadcast packets. And we're going to be going through those different protocols, and I did want to call out right up front the difference between broadcast and unicast, and we'll revisit it as we go on through these different protocols and look at different packet captures. And we'll talk about what the different addresses look like that would be unicast as opposed to broadcast. Now, what I've got up here in front of me is a packet capture tool called Wireshark. And what I was using before is a command line tool called TCP dump, which is available on most Unix-like operating systems, and you can also get it for Windows as well. But it's a utility that's primarily for Unix-like operating systems. I've got it running here on my Mac. There are also versions that are available for Linux and the various BSD flavors. So TCP dump is a pretty common packet capture tool. And what I can do with TCP dump is I can actually store the results of a capture, and it will get stored in a format that I can use inside of Wireshark. Wireshark, as you can see, is a graphical tool. We can look at the different protocols in a way that's more easy to understand. So I can just pop open a packet capture here, and you can see the same sort of thing. We've got the packets that are scrolling by, but they're actually broken out into columns. that are easier to understand, and you can see on the bottom here where it actually dissects the packet. And we'll get into how Wireshark works in a different lesson. The way that this works, Wireshark or TCP dump, is it puts a network interface into what's called promiscuous mode. So promiscuous mode allows us to see all traffic that crosses this particular network interface. And the network interface is there to block out traffic that's not specifically destined to us. So if we were on a different type of network that used a device that didn't filter those things, so if we were using a hub as opposed to a switch and all traffic on the network were being sent to us, the only thing we would normally see, or our operating system would normally see, is packets that were destined to us, that were unicast packets, or that were broadcast packets that everybody gets to see. Now, when we put a network device into promiscuous mode, everything comes up. Nothing is filtered any longer. So what we're seeing here is all traffic on the network, whether it's destined for us or whether it's not destined for us. So again, we'll get into more of the details around Wireshark in other lessons. And again, this is a tool that we're going to be using a lot as we go through the different lessons in this training video. So that's just an overview of doing packet capture. And again, I wanted to highlight the difference between unicast and broadcast. And I also wanted to mention the promiscuous mode, which is the mode that we put the interface in order to get all of the packets that are coming across the network interface, and they get pushed up into the network stack inside the operating system.